Now let's look at our first one-tailed test involving z-values, z-tests. In two-tailed tests, we have really no choice about our hypotheses. Actually have absolutely no choice. Two-tailed tests involving z. The null hypothesis will contain the equal sign, and the alternate will have the not equal sign. In one-tailed tests, we could have that null hypothesis has less than or equal to, and then the corresponding alternate will have a greater than, or the null could have a greater than or equal to sign in it, and the corresponding alternate there would be less than. In both cases, the equal sign is in the null, but beyond that, you could have greater than or less than in each hypothesis. So the question becomes, which tail test do we do for the particular example? As we'll go through, you'll notice that I do my logic a particular way. There are actually two ways of deciding which tail test. What I will do is to go for the best possible decision. The other way of doing it is to answer the question, but sometimes it leads you to a decision that's not very satisfying. In most cases, both ways will get you the same answer, but sometimes they deviate, and when we come across those will cause problems for some students. Anyway, we're looking for the best possible decision. What I'm going to do here is to show you the problem and then show you why we're going to do a particular tail test. So the problem that we're going to do is this one. The manager of a credit card department for an oil company would like to determine whether the average monthly balance for credit cards is more than $75. An auditor selects a random sample of 100 accounts and finds that the average owed is $83.40 with a standard deviation of $23.65. Using an alpha of 5%, should the auditor conclude that there is evidence that the average balance is more than 75. So in this question, it's obvious that we're talking about more than, which is versus less than, instead of equals versus not equals. So this is a one-tailed test. Alright, before we get into that though, let's get our sample data. And our sample data is in this sentence here. Alright, we have a sample size of 100, average of 83.40, and a standard deviation of those 100 items of 23.65. So let's write those down. Sample n is equal to 100. Alright, the average of 83.40. So x bar 83.4 and standard deviation 23.65. And the problem is the average balance more than $75. The more than tells us this is a one-tailed test. Alright, but for this problem we're going to look at this and decide which tail test to do. We have two alternatives. Either we're going to do an upper tail test or a lower tail test. Let's draw out two distributions and show you what happens. And the position that we'll take here involves understanding that we just derived from the logic of these tests. So let's talk about two different situations, A and B. In A, we're going to have the upper tail test with the entire alpha in that upper tail, and in B we're going to have a lower tail test with the entire alpha in that lower tail. Both of these distributions will be centered on the mean of $75. Alright, so to B first. The sample value of 83.4 is clearly in the upper part here, and is clearly in the acceptance region. Alright, and essentially we already know then without any calculations that we're going to say do not reject the null. Okay, which is a weak decision. Alright, alternative A here, the 83.4 could either be in the rejection region or the acceptance region, so we don't know. So either we will say again, do not reject the null, or we're going to say reject the null. At this point, without any calculations, we can't tell. Alright, so which of these is more meaningful to do? Well, it's quite obvious, I hope, that it's option A. Okay, we have the possibility of making a strong decision with rejecting the null. In option B, we have no such possibility. We are forced to a weak decision. So this is a upper tail test.